I'm going to send an invitation to Lance again. And then I think we are. Okay, I already sent the invitation. So, let's see. Okay, so you say the total area under a normal distribution curve must equal. What do you say, Pauline, about this? Oh, is she out too?
Pauline, I think, left and didn't know that we were staying in this group chat. You might
Okay,
want to send her another invitation.
let me invite her again. I sent an invitation already. Okay, so here she is.
Is that better?
Yeah, I think for us, for me, it's fine now. I send invitation to Lance, and maybe we can just keep going, and then I send invitation again. I don't know how would you like to do?
Is he not? Oh, yeah, he just has to start up his Chrome.
Okay.
He had to
Okay, so number one, yeah, there he is. There he is.
Okay.
Are we recording?
Yes, we are recording right now.
Okay. So the first two answers were just your personal answers. And then the total area under the normal distribution curve must equal, I think it's 1. What do you guys think?
According to the link you sent us, right?
Yes.
Well,
yeah, the number under the curve.
Yeah, I think it's 1.
Okay, and that's what I got on the test, the other one. And then number 4 is under certain circumstances, a normal distribution curve can drop below the axis line. And that would make it negative. So
no, it's not supposed to drop below the
Is that false?
I remember, right? It's
no, it's not supposed to.
Yeah, it's false, right?
That's
yeah. I remember reading that.
Okay. Does everybody agree with that?
Remember, it could go as close to the x-axis as you possibly can, but at no point can it actually ever like go below it or really touch it.
Yeah, that's what it said.
It can't be negative at all, so it can't go below at all.
It what, Ryan?
Well, it can't be negative at all in these probabilities, so it can't fall below the x-axis because then it would make it negative. So it can't drop below at all.
And then number 5 is a normal distribution curve is symmetric.
I'm not sure about that.
I think it's true.
Okay.
What do you guys think?
Yeah.
Okay, so number.
I trust in you, Pauline. So I think it's true.
Okay. All right. Yeah. No, it's true. Number 6 is which of the following elements of figures represent the z-score? And so on that, that thing there, C, is where you're putting in your Z-score after you finished all of your math problems, doing it the way that they told us to.
Uh-huh.
That was where I put in the Z-score, and then that's where it figured up the area on the top for me.
See. So what did you choose C, you said?
I put C, like cat. Cat was the Z-score. C, sorry, not cat, C.
Because it says represents the Z score, right?
Yeah. So after you figure out your math, and then you want to figure out what the area is using this applet, you put the Z-score down in those boxes.
Yeah.
Uh-huh.
And the two parameters. And okay, and then number 7, which of the following elements of the figure represents the probability that the Z-score will be greater than 1? And the greater than would be above. So I think it would be B.
That's what I just marked was B. I was guessing though. I remember I read the stuff, but I haven't worked through this stuff.
Okay.
I've worked 60 hours a week. This college stuff
Okay.
is like barely fits into my schedule.
Okay, and then the 68, 95, 99.7 rule, what percentage of the data from a bell-shaped distribution will be within one standard deviation of the mean? And they want it to you to write it as a percentage, just as a regular number rather than a proportion. And so going outwards, what were you going to say?
Well, the thing on here, for any bell-shaped distribution, 68% of the data will lie within one standard deviation of the mean.
Yep. That's what I think too.
And do we do 68% or do we do 0.6?
No, just the round the number with no decimals.
We're just doing 68%?
Yeah.
Yes.
Do we put a percent in there or?
No, just, well, I don't know. You can put one in there if you want to, but on his explanation up in the parentheses, it says to just write the number.
Okay, so all right, 68.
Yeah.
Salud.
Thank you.
What proportion of the Z-score will be between a -1 and a +1? So that's asking kind of the same question that was right above there, the 68%. Let me see here. I'm trying
to. Did anyone else notice that Moses is gone? Did he get kicked out or did he leave by himself?
Is it? Okay, let me invite him right now. Something happened. Okay, just give me a sec. Yeah. Sorry, I didn't notice it. Thank you for letting us know.
Well, I just noticed it myself. I was like, I think we're missing someone.
That or he was awful quiet.
Yeah, maybe when he's on, we can tell him what our answers are.
Do we get to use this applet? Do we save this applet for future stuff, or is this just?
Yeah, we're gonna be using it quite often in this course.
Oh yay! Joy.
Yep. So know how to use it. So I think we're supposed to put that -1 and 1 into the applet at that point, right? So we would just be using the area, and that's our answer for this one, right?
Which one are you on?
Number 9, right?
The question,
What are we
So
still
because
on
it's -1 and 1.
So you're talking about the area, the 0.3173.
Yeah, because it says to use the applet to answer this question, and then it gives us the z-score. So now we just would do the area, and it's asking for between -1 and 1.
So you're saying the point,
So we
are you saying to put the 0.317?
yes,
Okay.
because you would highlight the ends of it, both of the ends, and leave the middle white.
Okay.
Yeah,
0.31.
seems like that makes sense. Sure.
We'll just go with that. If I'm wrong, I'm sorry.
Okay. I'm kind of lost. So what number are we gonna put there in the area?
0.317.
Oh yeah, 7.3. Yeah.
So then on the next one, where we change those to -2 and 2, these scores will be it's just the area again, the 0.04.
Bless you.
Yeah.
Does that seem right?
10, right?
0.0.
Yes.
Yeah, that's all the way until 11. Now we just change it from 2 to 3. So I think he's just wanting us to get familiar with what it is.
Yeah, so I'm going to do 0.046 on 10, and then on, okay.
And then 0.003 on the next one.
Yeah. Okay, so 0.003. All right. Well, that little applet thing is pretty easy. Okay.
Yes.
Look carefully at your answers to the last 3 questions. What do you observe? Okay. Looking carefully at them. I got LASIK. I got new eyeballs. I see all sorts of things.
Well, they're definitely not. They're definitely not doubling. As the z-score increases, the area between them increases also. It's not decreasing.
So what do we think for number 12? I'm not entirely sure.
I think that the values match the rule.
Yeah.
And I don't know. I do know that that's right, but I only got that by deducting the other 2 because I don't really see where it follows the 68, 95, 97.
It definitely doesn't seem like as the z-score increases, it's not doing that. The area between that's not doing that. So I mean, out of those, the middle one is definitely not it. Probabilities double as you move from 1 to 2. That didn't do that.
Yeah, that's why I got the other one.
So, yeah, but I don't see the whole 68, 95, 99, 7 rule either. It's like I'm like looking at the paper here, reading it, and it's just like, huh? Okay.
I don't understand that either.
Yeah. Same here.
Okay, so out of those 3 choices, that seemed the one that was the most correct. And then okay, so then they want you to know that the amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. So the protein requirement is given in terms of numbers of grams of good quality protein that must be consumed each day per kilogram. And that requirement for an adult is 0.65 grams per kilograms per day. And then the population standard deviation is the 0.07. And then, okay, so I need to figure this out because I did this yesterday and so I forgot already what it was that I did. Because this is actual where we got to get out our piece of paper and pencil and do the math. This one is the percentage of distribution. No. This one is the Z. Yeah, this one was the Z equals X minus the mean over the standard deviation, the Z score.
Yeah.
So, and I'm simple-minded, so I have the mean was 0.65. So one deviation away from it, that each deviation is going to be 0.07. And then they want you to figure out the 60%. Let me see here. Let me see. Wow, I just did this last night. Why can't I think of what it is now? Not that. It's not that.
I haven't read much about this, so I'm not a good helper right now.
Okay, so it's going to be 60. Hold on, let me find it because, yeah, you can walk by it. So it's going to be 0.65. No, it's going to be 0.65 minus
0.07, right?
No, but minus the 0.60 divided by the 0.07.
0.60 divided by 0.07. Okay.
Let me see if I'm doing it right. Give me a second. I got to bring up I'm just going to do it on a scientific calculator because it's easier. Okay. So okay, so then we would do the 0.60 divided by the 0.07 first. And that I get is
8.57.
1. And then I'm going to minus the 0.65. And let me check. Whoops. Give the answer as a decimal.
2.53.
No, that wasn't it.
That came out to be 0.12, right?
No, that's not what I got. Hold on, that's not. I'm not doing something right.
It's supposed to be the Z-score. It's that X minus the mu round, and the mu is basically the mean squared, right? Or something like that. And then
The mean squared. No,
that gives you the standard deviation.
I don't know anything about squaring. I just know that when you square the standard deviation, you get the variance.
That's right, the variance, and then you have to take that and subtract that from the mean, and then I can't remember. Then you do like a square root in there, and that's where you get your Z. I could do this in Excel. I think there's a function in Excel that does the z-score.
So I think what it is that we need to take the protein required that is less than, which is the 0.60, and then minus it from the mean, which is the 0.65, and then divide by the standard deviation, which is 0.07.
Okay, we'll try that.
That's what I'm looking at, and that's how I was doing it earlier. Because if you look at the formula, it's taking that. It's the observation minus the mean, and then divided by the standard deviation. Then that's what the z-score is.
Okay, so the observation is the point.
I would assume that it would be the 0.60.
0. That's what they're actually observing, right? And then you take that parentheses. You're taking that and you subtract the mean from that, correct? Which would be the
yes.
Or do you subtract the standard deviation from that?
No, you divide by standard deviation.
Oh, okay. That's the that Greek weird the bait or
yeah,
whatever.
It's like the O with the little hat.
Yeah. So you take 0.60 minus we'll figure this out. Well, what am I subtracting from the 0.60?
You're subtracting 0.65 because that's the mean. They say the population mean protein requirement for adults is 0.65.
So you're going to get a negative there.
So it doesn't matter because the z-score is a negative and a positive.
Yeah.
So and it's asking for less than. So we're going to be only highlighting the bottom half of the applet. So that gets us 0.238 if we round up.
And that's the answer. So,
yeah,
so Ryan, tell me again, remind me, because I did this last night. I don't remember. What is it that you're doing? What did you put into the z-score on the...
So I put a negative because that's the answer I got. It doesn't matter either way because there's a negative and a positive. And so I put in 0.714.
That's what I did too. But I got 0.475 at the top.
Okay. So the reason why you did that is because you have the greater than also highlighted. You need to take that away and only highlight the less than. So the left side would only be highlighted.
Can you share your screen to help us understand that?
Yes, can you share your screen, please?
Yeah. Sorry, I'm babysitting right now, my kids. So my wife's.
Oh, cute baby.
Yeah, he's adorable. Let me see. So this is what I have right here. Like I said, that's what I'm getting, but this is my work right here. So I took the 0.60, minused it from the 0.65, and then divided by the standard deviation, and that got me the 0.714 because I rounded.
Yep.
That's the applet there.
That's perfect, yes.
Oh, and then you just put that in the applet.
Yes.
Yeah, and so I started off like that, and that's what you had, Pauline. And so I got rid of this because it just wanted the less than right there.
Okay. Okay, yep, that was right. I'm glad you figured that out. I just went over this stuff last night, and I'll be darned if I can remember it already. Then now all we have to do is shade the more than 60%, not the less than. So more than the 60% would be the middle one and the one above it on the applet on the curve.
So when I put 0.714 4 in the z-scores, right? How come my area went to 1?
Your area went to 1. Is it all shaded blue? Because if you shaded all blue, it will be 1.
Oh, I didn't. Oh, okay. I see now. All right.
Yeah, and
I
I
haven't
think
played with this
I think
stuff.
you're right on that, Pauline. So I think it would be 0.762.
Yep, that's what it is. And then the 70% is going to be the same thing. You're just going to do the 0.65 minus the 0.70, and then you're going to divide that by 0.07, and that's going to be still at 714.
Are we on 15 or 16?
We just moved to 15.
Okay.
Oh, I'm sorry.
762 on 14.
15 is kind of crazy because even though, so it was what is more than 60% on 14.
Oh, okay.
On number 15, the answer stays the same, the 0.762.
Yeah, it looks like it didn't make a huge difference because when I changed it out, it gave me the same 0.714 for the z-score.
Yes. And then if we're going to change that applet, so we would only shade just the middle part because they want to know between 60 and 70. It should be the 0.525 because you're rounding it to 3 decimal places. So it'd be the 0.525.
For 16.525.
Yeah, do you guys see why? Because you changed the shade on both sides, you got rid of it, and you're doing just the middle, and then you look at the top.
Yeah, I got you.
Not letting me get rid of the blue on the right-hand side outside of the red, but
Yeah, the right and the left. Get rid of that, and then you'll see.
My thing's not working. It's not letting. I click in the thing to try to not have it colored, and it doesn't do anything.
Maybe your
broken.
Your applet's broken. That stinks. Okay.
Yeah, it only lets me color the center one or the left side, and it stays blue on the right side. Oh crap! Something just happened. Ah!
You might have to go out and come back in from that applet.
Oh, there you are. Maybe, yeah. Okay. All right.
Okay, so now to figure out the percentiles, that was a different equation. That was the percentage of distribution, maybe. And that was X, which would be the 60 or, no, what is the thing here? We want to know the 35%, 35th percentile. Thirty-fifth percentile. Huh. Let's see. Anybody have any idea of how to do that? I've got
the preparation stuff for this doesn't prepare us for these things.
Okay, so I think that
so I was just kind of reading through the lesson again, and it says that to find the like for example, the 90th percentile, click on the regions of the graph so that the left of one of the bars is shaded and nothing is shaded to the right. Then type in 0.9 in the box on the top and press enter. And the z-score will have the value of 1.282, and it will be the 90th percent to the left. So what we would want to do is take our applet and shade like to the lower half, I think, and put in the area 0.35 and hit enter, and that should give us the 30th, the
35th,
35th, right?
0.935. So the z-scores.
I don't think it's 9. I don't think it's 935. I think it's just 0.35.
0.35 is the area, right?
Yeah.
That's what I did, and then the z-score ended up being 0.935.
Did you?
Yeah,
how far did you shade? Because I think you're only supposed to shade to the left.
Like I said, my applet's broken. My right side's always shaded. I can't unshade that.
Yeah. In
You
here,
want the right to be shaded?
No, I'm sorry.
I want the left to be shaded.
Only the left.
Yeah, I got a retarded applet here. It's not letting me do anything other than shade the center and the.
It's the same to me. I got the same amount that you are saying, Lance.
But my right side's shaded, and it shouldn't be. I can't unshade it.
So so Ryan, what did you say that you did? You put in the z-score as what?
I didn't put in the z-score as anything. I went to the area.
Go to the area, right, and put 0.35 in there, correct?
0.35, and then you do the area to
0.35.
So it does say click on the areas under the curve until only the left area, the area left of the positive of the z-score is shaded.
Let me reopen my applet. I've closed mine out. Maybe.
So I think it's actually supposed to be the middle and the left, and then we do 0.35. Oh, actually, no, it doesn't matter. It'll just shade it automatically if you do the area. So then we get a z-score of 0.385.
0.385. That's now, I closed mine out, started over. Yeah, so I get 0.385 now.
So you got that too.
Yeah.
And so I think that's what they're asking for, because when I'm reading through the lesson, it doesn't say anything else that we really need to do. Looks like we can do some substitute values, but I don't think that's what they're wanting.
So what is the answer that you're getting, Ryan?
Right now I'm getting 0.385.
Okay, that's not the answer.
That's not the answer. So then I guess we have to do this.
But I'm not sure what the answer is. I got it right last night, but I can't figure out how I got it that way.
So I think that we need to do the substituting the values. So trying to find x. So we need to put in the z-score and then the mean and the standard deviation and solve for x, which will be that.
Okay, so
yeah,
okay.
I think
find the probability.
So
it's not 0.385?
No.
Mm.
Okay, so x equals the percentage of the normal distribution. The equation for that is x equals the mean plus the z-score times the standard deviation. So we just need to plug that in somehow. So the mean is 0.65 plus the z-score.
Oh, my family's trying to FaceTime me since I haven't seen them all day.
0.714
Ah.
is what?
Good night, Daddy.
Good night, kiddo. Love you.
Good night.
Micah, he doesn't get to see her. He farted through the whole prayer.
So,
I love you. We're still online in a quiz. I love you.
What?
I said I'm online on a quiz with my group. I gotta get off.
Okay, so you gotta go. Just say good night. Bye.
Yeah, love you.
Love you.
so,
I come to the
you
office.
did it? Did you
I'm
do
almost
this
done. Close
solve
the door,
for
honey.
X then?
The standard deviation. No, I have to be able to hear them. The
Pauline?
standard deviation. I'm sorry, Ryan, what did you say?
Oh, I was asking you if you did this equation. You basically put everything in, and you're solving for X, which is the I forget what it's called. But basically, what we were doing before, just in reverse, where we have the z-score now, and we're not trying to find the z-score. Now we are using the z-score and equaling it out to X minus the mean, and then divided by the standard deviation, right?
Yes. So I
Okay.
think it's,
Okay.
let me see.
So then we have to times by, once we get everything plugged in, we need to times by the standard deviation on both sides.
So I got 0.714 times 0.07. That equals 0.049, and I'm going to do plus 0.65. No, that didn't do it either.
X minus-
Yeah, why didn't you write down your answers from last night?
I know, because I'm a dork. I threw it away.
What questions are you guys on? I just came back. What is that?
We're number 17.
17?
Yes.
I don't know. I've been here since 6 a.m.
Moses,
Okay,
do you know the number to 17?
Let me see.
So I think I might have an answer for it. And you said you got it right, Pauline?
Yeah, I did.
So I got 0.677.
No, it's 0.623.
6.
I'll just be darned if I forgot how I got that.
Huh.
Or number 17 is 0.623.
Yeah.
Wow. Mean
Yes,
plus score divided by the standard deviation.
17 and 18 gave me a lot. I was doing it for hours and I can't. 35th percentile. How you've got to be able to put that in somewhere.
I think I know where I went wrong. Hang on, I did something wrong.
The standard mean is the 0.06 or 0.65 plus the z-score What are you using for the z-score?
I'm using the 0.385 that's in the applet. It's
0.35. So if you're using the 0.385 minus 0.07. Let me see what that gets. .385 times 0.07 is 0.0265. 0.695 plus 0.65. Okay. So let's do 0.35 times 0.07. That's 0.0245. I'm going to plus that by 0.65. 0.674. All right. I have no idea how I did this.
I think I see where I went wrong. Okay, give me 1 second. Let me try this out. And what did you say the answer was that you got?
0.623.
Let's see.
We're working on number 17, 35 percentile of the protein requirements. I'm
Oh,
gonna
so
be
you want me to go back and mention what all the other ones that we've gotten there?
what is your question?
Is Moses here?
Yeah, I'm right here.
Are you caught up with us? Do you need to get caught up?
No, I'm not. I was trying to figure out how to get back to the. But that's okay. I'll just go over the video later on.
I'm gonna have to write down how I got these answers next time. Is this I'm getting perplexed. I had to go through the stuff quite a bit. One standard deviation. The 35th percentile. 0.0. .623.
Give me that answer one more time, Pauline, just so I can kind of try and figure out what I'm doing wrong.
The answer for 17 is 0.623.
6.623. Man.
And I even put that in as the z-score, and it didn't give me anything. So
And you said 17, right?
yeah. I don't think it has anything to do with the applet. I think it has to do with.
How are we supposed to get the z-score then?
Okay, so find the probability that a randomly selected person will have a protein requirement of between 60 and 70. What does it say here? Find the 35th percentile. Remember to find the area between the two values. Shade. To the left of each z-score, You calculate and then subtract the smaller from the larger. Are you coming up anywhere around 0.623?
I got really close to it. I got 0.677.
Yeah, I got that too. On
I'm wondering, like, if we can be within a certain, like, if he gives a grace period of it, or if we have to be dead on kind of thing. Because I almost want to try this 0.677 because I don't know what I would be doing wrong at this.
Okay, we'll try that and see, and then we'll
Okay.
submit both of them and then see what comes of that.
I'll submit mine right now so I can just see if this is actually going to work. And then if so, then
Well, we have to do the last one too. Did you figure that one out?
I'm going to just see if I'm even doing it right. No, that's not right. Dang it. Oh, man. So there's something wrong with how it's being done, but I don't understand how.
The mean plus the z-score it's not the empirical
I
rule.
also got 9 through 11 wrong.
9
Yeah.
through 11.
Yeah, the
Hold
one where
on.
we entered the z-score, 1 and -1 and 1.
Let me see what I got on 9 through 11 on the
9 was 0.317.
Yeah, that one's wrong.
Oh,
9. Okay, so what did you put for number 9? I'm sorry, Ryan.
We all put 0.317.
Okay, last night when I did the test and then I missed 9 through 11, I went through and I figured out what I thought that it was, and I came up with a different answer than what we came up with today. But I just went along with you guys is because I figured maybe I did something wrong. So on number 9, I did 0.683.
okay.
Let me go back to 9.
Also, 15's wrong.
0.683. And number 10, I did 0.954. And then on number 10 or 11, then I did 0.997. And I'm wondering if that isn't because if you look at the rules, the 997 is the 99.7%, then the 95.4, and then the 68.3.
There you go. That would make sense.
Okay,
But
hang on,
you
let me
said you
get-
missed number 15?
Yeah, 15 was wrong also.
Let me see what I...
That was the 0.762. That was wrong.
Sorry, what?
I got it right, and it was 0.762.
0.762. For 15, I had put 0.238.
What number was that?
15.
Wasn't that? I just changed my 16 to 5. 0.525. Wasn't that 0.328 or 0.238 or whatever it was?
16 was right.
At
What was 16 again?
0.525?
Sorry, what was it?
16 is 5.525.
Okay.
0.525. Okay, yeah, that one was right. It was number 15 that was incorrect.
Number 15 I got right, and that was 0.762.
Oh, somehow I think I put it in then. Because I think we had talked about that earlier, and I don't know how I got that wrong. Maybe. Okay, well, just so everyone makes sure they check their answer on that one.
And so number 15 is 0.762. 16 is 0.525. 17 is 0.623. 18 is 0.709.
Uh-huh.
I want to figure out why I'm getting such a wrong answer to that. And then
Yes,
what did we do? So what was it 9 through 11? I didn't understand what you were saying on that, Pauline.
So on that rule of the 65, 95, 90, I don't know what the rule is now. Let me look it up. I've got it written on flashcards.
68, 98,
5997.
yeah.
Yes. So I think that they on number 9, it was the 60.683 because that was the 68 rule.
0.683.
Yeah, 0.683. And then the other one was the 0.954.
954. Okay.
And then the 0.997.
Okay. So, do we give the score for those and then place in? Wait, I'm kind of like I'm trying to figure this out. Because are we supposed to put that into the applet then, or?
No, I don't
Yeah,
think you put.
when you put it in the applet, it comes up with those numbers. I'm just doing it right now. You just have to have the center portion colored in, and then go down and then it's your area works those numbers.
Oh, I see. Okay, I see what you're saying. That makes sense. So
Yeah,
we just
so
have the middle portions.
the applet makes it pretty easy for us if on those.
It just depends on if we can actually figure out how to use it.
Yeah.
Yeah, that's the thing.
Okay, so
Well, I'm at a loss on this percentile stuff, but
I'm gonna do some more homework on that and try and figure it out. But since if you had the right answers, Pauline, I'll try and figure it out a little bit later, and if I can figure it out, I'll share it out. I'll share it with the group.
okay.
You can text us.
I'm at 14 and a half hours today at the office. I come in at 6 and every day, so.
Yeah, if I can figure it out, I'll go ahead and write it all in, and then I'll just send through that email link, and I'll send a picture of what I.
Yes, please.
Yeah, and then honestly, if I see the math, I mean, I could probably build us an Excel spreadsheet that'll do it for us.
Yeah, my biggest problem is I don't know what I'm doing wrong, so I'm gonna have to take a look at what I'm doing incorrectly and go from there. So
I missed number 10. That was it.
On this one?
Yeah. So the 0.954, I don't know what it is.
Well, let me plug it into the applet. I didn't do that. Just a second. I did it on the other one. So that's the -2 one?
Yeah.
Yes, -2 and 2.
0.955. Got to round up.
Oh, yep, 0.955. You'll get 100% then.
Uh,
Okay, I'm submitting.
Me too.